Hi, welcome to section 5. A recap of what we've been doing is we have been dealing with tests. We know about the integral test, and we just went through a section that dealt with the comparison test and the limit comparison test, right? And they're going to take practice in order to get proficient at that. But in all of these guys, we dealt with positive term series. The only time we dealt with negative term series was way back in section 2, where we were dealing with geometric and telescope, even the telescoping with the way we set them up. Geometric series, might be, negative, but we've been spending a lot of time on this area lately. Well, finally in this section, we talk about what they call alternating series. And this is where the terms in the series change sign from negative to positive, positive to negative, negative, positive, like green light, red light, green light, red light. And first of all, what does that look like? Well, they achieved this the following way. Oh, and by the way, we're going to break this guy up into two videos as well. The first video will be talking about how to run the alternating series test, and the second one will deal with the one and only error estimate that we do in this chapter, which is the alternating series error estimate. Okay, so that's the second video. For this one, what does an alternating series look like if we're looking at it in the homework? Well, all three of these guys alternate in sign. Let's investigate these guys. And the way you investigate it is you just basically go, I'm going to write out terms. If n is equal to 0, I've got a negative 1 on top, and downstairs I've got the square root of 1. If n is equal to 1, I've got 1 plus 1, so it's plus 1 over square root of 2. Oh, I get it. Minus 1 over square root of 3 plus, see how it alternates? The reason it alternates, pretty easy to see. It's the minus 1 to a power causes the sign to alternate. Okay, that's what it looks like. So there's a negative in this case, a positive, a negative, a positive, and they just alternate in sign. Okay, look at the next one. That looks like, what? Cosine, what the heck? Oh, where's the comparison test? Wait. Just write out a few terms. All we're doing is looking to see how it alternates in sign. So if n is 0, well, it shouldn't be, because look, you get a 0. I'll write it in anyway. The first term is 0, silly me. But then it goes, what's the next one? Plus n is 1 cosine of pi times 1 all over 2 to the 1. Next one, n is 2 cosine 2 pi all over 2 squared. And then plus 3 cosine 3 pi all over 2 to the 3, plus, etc. But what's happening inside the cosine, right? What we have is cosine of pi. And cosine of pi is negative 1 over 2. Cosine of 2 pi is 1, positive 1 over 4. 3 pi, negative 1 over 8. Isn't that cute? It also alternates in sign because these are multiples. Right there it is, right there. Multiples of pi in cosine. They will flicker, and you can do it with sine also. You could. Pi over 2 times n. Okay, that would work. And the third one, let's look at the terms here. Well, the first one, n is 0. You get the 0 power, which is, see, I messed up again. So each of these, if I were to do this speech again, I'd go, that's a 1, make that a 1. So we have to make that guy a 1. So now consider n is equal to 1. Well, we get negative 1/3 to the 1 all over 1, plus negative 1/3 to the 2, when n is 2, over 2, plus, you see what's happening? Negative 1/3 to the 3 over 3, plus, etc. Well, that guy flickers. It's going to be negative 1/3, okay, over 1. It gets squared, so it becomes positive 1/9 over 2, negative 1 over 27 over 3 positive, and once again, yeah. So what I'm showing you is these signs change plus minus this time caused by a base that is negative taken to higher and higher powers. Okay, so that's how you get it done. What does it look like? What are we interested here in terms of the alternating series? Here's the thing. Here we go again, if you look at the sequence of partial sums, okay, then what you're getting is, well, you can look at any of these. Maybe we look at this one for fun. Maybe not. Let's do it in general. So you have like an A1, but then it's a minus A2, and it's a plus A3, and it's a minus A4, whatever that is. Okay, I think we got one down here somewhere on the next page that we get to play with. Sure, we'll do that. What it tends to do, and then plus, etc., is you got a number line, and if you look at, that's not a number line, it's got all tilted. Let's do that, not much better. And if you look at it, S sub 1 is the first term. And then S sub 2 is A1 minus A2. And S sub 3 is A1 minus A2 plus A3. And then so on and so on and so on. So you start at 0, let's say, and the first number you add is A1. Okay, we'll do it again on the next page. But then you subtract another number. Wherever you land, you land. I don't know where you land. So this right here is S sub 2. It's equal to A1 minus A2. Do you see that? I'm going to add A1 minus A2. Add A3 minus A4. And it bounces back and forth, back and forth. Okay? Something about that led mathematicians of the past to say, I know when this guy converges and I can prove it. Okay, so that becomes the alternating series test. And that takes us to the next page. Okay, so down here, you actually have the alternating series test. What it does is it tests to see if an alternating series converges. Right? All right, and that's, of course, it's typed up as well. I just wanted to write it out. Want to see if it converges, okay? So the hypothesis is that you have an alternating series, and the two things that happen. One, this is what you check. One, the magnitude A sub n is decreasing. Here we go again with that, and that's what it looks like mathematically. And the magnitude A sub n decreasing to 0. That means the limit. Those are the two things you check. You check to see if the terms are going decreasing to 0. Why is that a thing before we look at that? Let's explore this guy, the so-called alternating harmonic series. Now, when you look at this guy's terms, the first one is 1. But then the next one, when n is 2, you get negative 1 over 2, positive 1 over 3, negative 1 over 4, positive 1 over 5, negative forever, okay? That is a lot like the harmonic series, right? Remember the harmonic series? Let me put it back here. Recall the harmonic series, all right? And that was series n is 0 to infinity, I think, or is it 1 to infinity? Doesn't matter. We'll just go 1 to infinity, and it's going to be 1 over n. So it equals 1 plus a half, plus a third, plus a fourth, plus a fifth, etc. And he diverges. So the question is, what about if it alternates in sign? What does that look like? Remember the sequence of partial sums. Let's look at these guys. The sequence, and once again, of partial sums. It tells two things. It tells us about convergence, but also it tells us about the error. Next video. Okay, so S sub 1 is 1. S sub 2 is 1 minus a half, which, by the way, is 1/2, isn't it? S sub 3 is 1 minus a half, but then plus a third, and I think that takes us to 5/6 if I'm not mistaken. S sub 4, well, you get the point. It's 1 minus a half plus a third minus a fourth, and then S sub 5 is, and you just keep going. But what does that look? It's, if you look in a textbook, they always do this. You start at 0, and then with this guy, you add 1. You start off with 1. That's where you are first. That's this guy. But then you subtract minus a half, right? And this is S sub 2 right there, which is, it turns out to be 1/2. But then you add a third. You're adding a third. So this is S sub 3 here now. And it ends up being 5/6. And then you subtract a fourth, and it just keeps on bouncing. It just keeps on bouncing. Here's the punchline. If this guy actually has a limit, wherever it is, he's got to be nestled in here somewhere. That is to say, you could say that's the sum. I'll get rid of L and call it, that's the actual sum. That's what we're looking for. But here's the funny thing about it, and I'll talk about it on the next video too. Every time you add, in this particular series, these guys, the terms are getting smaller and smaller and smaller. Shouldn't have done that in red. So what happens is, they just keep going back and forth and back, and they are shrinking towards the limit itself. Okay, so the two things that you look for in this test is the following. To run the alternating series test, and we're doing it, let's say on this guy, series n is equal to 1 to infinity. And then I said something like, am I doing that right? 0 to infinity. I got that one wrong. Watch those limits, man. And it says minus 1 to the n times, oh, I did it wrong. Sorry. I was looking in the wrong spot. Okay. That's pretty typical Weber. So we've got series n is 1 to infinity, minus 1 to the n minus 1 over n. Okay, that's the alternating harmonic series. Two things you check. Check. One, take this guy, and I'm going to rewrite it. It's series n equals 1 to infinity. There's the part that causes it to alternate, right? The minus 1 power. But then you have the meat, if you will, of the term, the magnitude of the term. To run the test, you ignore the alternating part. You realize it's alternating. But then what you do is you want to show that it's decreasing to 0. So number 1, the lim, very easy part, n goes to infinity, 1 over n is 0. So it is going to 0. Number 2, an is equal to 1 over n, but 1 over n plus 1, that is an plus 1. It's got a bigger denominator, so he's smaller, decreasing. Punchline, series, oops, let me write it that way. Series minus 1 to the n minus 1, n equals 1 to infinity over n converges. Those are the two things you have to check. Is it decreasing to 0? If it doesn't go to 0, okay, we've got some examples there. If lim n goes to infinity of a sub n does not equal 0, then what you have is this case of it's bouncing, whatever the limit is, it never shrinks any lower, and it just bounces back and forth, back and forth. In the other case, if not decreasing, and this one I just kind of dreamt up on my own, then it's going to bounce and then bounce a little, and then bounce and bounce a little. It's going to 0 eventually, but it might wander off the map to unbounded world. It could do that. So you have to have these two cases for convergence. Yet more tests to remember, right? Okay, we're not done yet. We're almost done. We got another big test next section, but this is the penultimate one, if you will. So I'm going to finish this video by running that test on these examples that I showed you earlier. Okay? Each one we know alternates. So in each one we say, I'm going to run the alternating series test. I'm going to run the alternating series test. All right. And finally, I'm going to run the alternating series test. Beautiful voice, series test. I think I'm losing it. Okay, in each case, that's what we're doing. We're running the alternating series test. Okay, how do you do it? Well, okay, you guys have to remember, we're going to detach it, all right, from its -1 thingy that causes it to flip-flop sign. So I'm going to run this guy on the 1 over square root of n plus 1. Okay, I hear someone coming. Needs help on calculus, probably. Okay, so number 1, lim n goes to infinity of 1 over square root n plus 1. Look at it, look at it, look at it. Yep, 0. 2, a sub n is equal to 1 over square root n plus 1. But if I plug in an n plus 1 in that, square root of n plus 1, let me get that better. N plus 1, that's an plus 1. You notice, you know what? Yeah, it's a bigger denominator. It's decreasing. What's the story? It converges. It's as simple as that. Okay, that's how it's done. Go to the next one. All right, now I'm going to detach the thingy that causes this to be alternating. And so I'm going to look at, okay, 1, lim, as n goes to infinity of n over 2 to the n. Well, right now what we've got is infinity over infinity, so it looks like we might have to run Mr. L'Hopital on that one. Let's do it. So it's equal to lim, as n goes to infinity of 1, derive n, or x, and downstairs, how does this go again? 2 to the n times ln2, I think. Regardless, as n goes to infinity, this guy goes to 0, so part 1 is done. Now this one, I haven't really looked at. I might have trouble here, but I'm going to try it anyway. We're supposed to show that it's decreasing, but if I compare n to the over 2 to the n and n plus 1 over 2 to the n plus 1, I'm not sure, so I might have to use the first derivative test on this. So let's see what happens. First derivative test. Let's let f of x equal x over 2 to the x. F prime of x, therefore, is going to be 2 to the x squared, and then 2 to the x times 1 minus x times 2 to the x ln 2. Okay, I don't know what's happening. So f prime of x is, take out 2 to the x, and inside here you've got, therefore, 1 minus x ln 2 all over 2 to the 2x. Okay, and you can cancel those powers if you want. Really, I think the nugget of truth is right here. Okay, I mean, it's got a 0 when x is equal to, what is it? 1 over natural log of 2. So f prime is equal to 0 when x is equal to 1 over natural log of 2. Got this number line. That's probably really small. So really, we're looking at testing the sign with a number. So if you plug in some number bigger than, like, plug in 10 or something like that, you've got 1, might forget about it. Yeah, it's definitely negative. It's decreasing. That took a while, but we do have, therefore, this implies a series, what did we say? That whole thing. So n cosine of pi n all over 2 to the n converges. Okay, and you have one more. So let's do this last one. That one, you know, I know you're going to be mulling over the first derivative test, how that went. You're watching a math teacher, a calculus teacher do the first derivative test with ease, right? You might be struggling with that. But I'm going to tell you, if you know what to do, and you might fumble on the first derivative test, or I wouldn't spend a whole lot of time on that if you're taking an exam, but I'd circle it and come back, certainly. And so let's do one more. The part of this guy that's causing it to flip-flop and flip and flop is the -1/3. Well, I don't remove that. What I do is I go series -1 to the n, and then 1/3 to the n over n. So 1 is this guy. What's the limit of that? Well, that's a pretty good question, isn't it? Lim, as n goes to infinity. Should I just let you do this? Oh, no? Okay. So I got like 1/3 to the n over n. And that guy, once again, goes to, well, no, wait a minute. As n goes to infinity, the top goes to 0 over infinity. So that's definitely 0. We're in great shape. All right. And number 2, it might be that we have to take the first derivative test again. And I'll let you try that one because this is getting to be a longish tape. So I would have to go through it again, but you're finding that this is the process, and typically what happens is you run through those 2 checks and your alternating series converges. If you want to see one that doesn't work, you can make one up like, what about series like n is equal to 1 to infinity minus 1 to the n, and then you do something like 3n plus 1 over 2n plus 5. And look at this thing. This guy does not go to 0 because, in fact, what he does, if you take his limit, is 3 over 2, which is not 0. You know what you do in that case? Run the divergence test. The divergence test implies this guy diverges. You don't even have the terms going to 0. So that's a quick counterexample, and I think that's all she wrote for this first particular video. The second one is going to deal with, when we add these guys up, what's the error of our estimate of the actual sum? Okay? So thanks for listening. Hope that helps.